Welcome, everyone. Let's get started. Today, we are transitioning from the laboratory of model development into the reality of production. We will master how to deploy machine learning models as real-time or batch endpoints using managed inference options in Azure. This is where your AI finally generates tangible business value. Let's begin by defining what we mean by production deployment. Deployment is the critical process of taking a trained machine learning model and hosting it so it can receive new data and generate actionable predictions. In the MLOps architecture, this is the transition from the inner loop of model development to the outer loop of production. Why is this so crucial? Simply put, a highly accurate model sitting locally on a data scientist's laptop provides absolutely zero value to the business. It must be hosted. How do we do this? We package the model and deploy it to managed endpoints in Azure. The deep dive here is the word managed. In the past, deploying a model meant manually configuring web servers, setting up Docker containers, and managing load balancers. With managed inference, Azure abstracts all of that infrastructure away. It provisions the VMs, handles security, and manages scale automatically. Take a look at this high-level flowchart. On the left, we have the inner loop where our data scientists explore data and train models. Once a model is successful, we move to the middle step, packaging and registering the model into a central registry. This acts as the bridge. We then cross over into the outer loop, representing our deployment phase, ending at the green managed inference endpoint. This endpoint is the secure, scalable API that your business applications will ultimately talk to. When we deploy, we must choose how the model will be consumed. We have two primary architectures: online endpoints, which provide real-time predictions, and batch endpoints for asynchronous processing. The basics are straightforward. An online endpoint acts like a web server, waiting for a request and replying instantly. A batch endpoint processes massive amounts of data from cloud storage on a scheduled basis. Why does this matter? It dictates both your user experience and your cloud bill. You shouldn't pay for always-on, real-time compute if you only need a nightly analytics report. How do you choose? You match the endpoint to the application's latency needs. Diving deeper, online endpoints require dedicated, continuously running VMs to guarantee millisecond latency. Batch endpoints, however, are ephemeral. They dynamically spin up a massive cluster, process terabytes of data, write the predictions back to storage, and then spin down to zero, saving significant money. This decision tree breaks down the architectural choice. Starting from our registered model, we hit the deployment type decision node. If the business application has a real-time need like a user waiting on a web page, we route to the online endpoint, which utilizes dedicated always-on compute to deliver millisecond latency. If the requirement is handling large data asynchronously, we route to the batch endpoint. This utilizes ephemeral scalable compute to deliver high throughput while remaining highly cost-optimized. Before we can spin up an endpoint, we must properly package our model. To do this, we use MLflow. What is MLflow? It is a powerful open-source platform deeply integrated into Azure Machine Learning that standardizes how models are saved. The basics: after training, your model must be registered in the Azure workspace. MLflow captures not just the model weights, but all associated metadata. Why is this critical? Because deploying a model without its exact dependencies will cause immediate crashes. Standardized packaging guarantees the production environment perfectly mirrors the training environment. How is this done? By enabling MLflow auto-logging during your training loop, Azure handles this packaging automatically. For a deep dive, understand that the MLflow format generates a self-contained folder. Inside is an ML model file that explicitly lists every Python package and version required. This entirely eliminates the classic engineering nightmare of "it works on my machine but fails in production." Observe the MLflow packaging process in this block diagram. On the left, we have our raw assets: the trained model weights, the Python dependencies, and the performance metrics. All three of these independent streams flow into the MLflow packaging engine. The engine binds them together into a single, cohesive unit and registers it into the Azure ML model registry in the center. The output on the right is a standardized MLflow artifact, fully prepped and ready for seamless deployment. Because we used MLflow to package our model, we unlock one of Azure's most powerful features: no-code deployment. What is this? It is the ability to deploy your model to a live online endpoint without writing any custom infrastructure or routing code. The basics: in traditional MLOps, a developer had to manually write a scoring script, a Python file that intercepts the web request, parses the JSON, feeds it to the model, and formats the response along with a custom Docker file. Why change this? Because writing boilerplate API code is tedious and delays time to market. How does no-code fix this? When you deploy an MFlow model, Azure takes over. It auto-generates the scoring script and the container. The deep dive reason this works is the MFlow schema. Because MFlow explicitly records the exact input and output data types the model expects, the Azure Managed Endpoint can dynamically construct a secure, highly performant REST API around it on the fly. This flow shows the magic of the no-code deployment engine. We push our registered MFlow model into the engine. Notice how the flow diverges. The engine automatically generates the scoring script on the left and the Docker environment on the right. You didn't have to code either of these. These auto-generated components merge seamlessly into the managed online endpoint, resulting in a secure REST API that is instantly ready to accept traffic from your applications. To achieve true enterprise maturity, we must automate our deployment process using GitHub Actions. What does this mean? We use continuous integration and continuous deployment pipelines to provision our endpoints automatically. The basics: instead of a human manually clicking buttons in the Azure portal, we define our deployment rules in a YAML file. Why is this critical? Manual deployments are notorious for human error. A single misconfigured setting can bring down a production app. Automation guarantees identical, audited rollouts every single time. How is it implemented? We write a GitHub Actions workflow that executes Azure ML CLI v2 commands, specifically AZML online endpoint create. Diving into security, we never hard-code passwords. We store an Azure Service Principal in GitHub Secrets. When a new model is merged, GitHub securely authenticates to Azure, provisions the compute, and deploys the new model to the managed endpoint completely hand-free. Let's walk through the CI/CD sequence. The MLOps engineer merges approved code, triggering the GitHub action. GitHub securely authenticates with the Azure ML CLI. The CLI first commands Azure to create the foundational managed endpoint. Once the compute is provisioned, the CLI sends a second command to create the actual deployment, injecting our MFlow model into that endpoint. Finally, the endpoint reports back that it is live and ready to route 100% of traffic to the new model. Automation is incredibly fast, which means it can break things incredibly fast. We must safeguard our production environment using a human-in-the-loop strategy. What is this? It involves placing manual approval gates inside our automated GitHub Actions workflow. The basics: we never deploy straight to production. We deploy to a staging endpoint first. Why? Because while code syntax can be verified automatically, machine learning models can exhibit subtle issues like bias or data drift that require human intuition to catch. How do we build this? We use GitHub environments to enforce required reviewers. For a deep dive into the workflow, GitHub deploys the model to staging and then literally pauses the pipeline. A designated stakeholder receives an alert. They log in, review the staging endpoint metrics and the responsible AI dashboard, and only if the model is safe, they click Approve. This action unpauses the pipeline, routing the model to production. This flow highlights the safety gate. The CI/CD pipeline triggers and deploys the model to a staging endpoint. Automated integration tests run immediately. Then, we hit the yellow diamond, the human approval gate. The entire automation process halts here. If the reviewer spots an anomaly in the predictions, they reject it, and the pipeline safely rolls back. If the metrics look great, they approve it, and the pipeline proceeds to update the live production endpoint. Let's apply this to a highly important real-world use case. Consider Prosware, a healthcare startup. Their data science team built a powerful diabetes classification model. The challenge: doctors use a web application to input patient vitals during live consultations. They need immediate diagnostic insights while the patient is sitting right in front of them. They cannot wait 5 minutes for a result. The implementation: the MLOps team uses GitHub Actions to deploy the packaged MFlow model specifically to an Azure managed online endpoint. The execution is seamless. The moment the doctor hits Submit on the web app, a secure REST API call hits the endpoint. The result: because the online endpoint utilizes dedicated, always-on compute, it processes the patient's data in milliseconds. It returns the diabetes probability score instantly to the screen, directly empowering the doctor's real-time medical decision-making process. Let's trace the real-time data path for Prosware. The doctor at the top enters patient vitals into the web app. The app immediately fires an HTTPS post request down to the Azure Managed Online Endpoint. The endpoint feeds the vitals into the diabetes classification model. The model calculates the probability score, hands it back to the endpoint, which fires the response back to the web app in under 100 milliseconds. The doctor gets their insight instantly. To contrast the real-time scenario, let's look at Proseware's second challenge. They just acquired a legacy database containing 500,000 historical patient records. They need to run retroactive diabetes risk analysis on all of them. The challenge, if they send 500,000 requests to the real-time online endpoint, they will overwhelm the API and generate a massive, unnecessary cloud compute bill. The implementation, the team takes the exact same MFlow model, but deploys it to an Azure-managed batch endpoint instead. The execution, a scheduled nightly job triggers the batch endpoint, pointing it to the cloud storage where the legacy data lives. The result is pure efficiency. Azure dynamically spins up a massive compute cluster, processes all 500,000 records asynchronously in parallel, saves the predictions directly to a secure database, and then completely destroys the compute cluster so Proseware stops paying for it. Right tool for the right job. In our final diagram, we see the batch processing architecture. Data is extracted from the legacy database into Azure Blob Storage. A scheduled trigger hits the managed batch endpoint. The endpoint spins up a cluster for parallel model scoring, crunching massive amounts of data asynchronously. Once finished, it writes the predictions to the analytics database and completely destroys the compute cluster to save money. Finally, those insights are surfaced on a population health dashboard the next morning.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see this is all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepare for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.